Hello friends, in class 12th the P block elements. Now we will start the group 16 elements, and in this video we will discuss about occurrence, atomic properties, physical properties and oxidation states of group 16 elements. First come, what are the elements present in group 16? These elements are also known as chalcogen. Actually, this word chalcogen is derived from the Greek and its meaning is copper. Okay, and the term was also used for bronze or brass. Actually, bronze and brass also contains main element as copper. Okay, and most copper minerals contain either oxygen or sulfur, and these belong to the group 16 elements. That's why group 16 elements are also known as chalcogen. Clear? These are the elements present in this group: oxygen, sulfur, selenium, tellurium, polonium and livermorium. Okay, these two, polonium and livermorium, these are the radioactive elements. Occurrence. Oxygen is the most abundant element on the earth crust. Okay, this is most abundant. It forms about 46.6% by mass of earth's crust, and dry air, that is in atmosphere, contains 20.946, roughly we can say 21% oxygen by volume. The abundance of sulfur in the earth's crust is only 0.03 to 0.1%. In combined sulfur exists primarily as sulfates such as gypsum CaSO4 2H2O, Epsom salt MgSO4.7H2O, barite BaSO4, sulfides such as galena PbS, zinc blende ZnS, copper pyrites CuFeS2. These are the some minerals of sulfur. Traces of sulfur occur as hydrogen sulfide in volcanoes. Clear? Organic materials such as eggs, proteins, garlic, onion, mustard, hair and wool also contain sulfur. Selenium and tellurium also found as metal selenides and tellurides in sulfide ores. Polonium occurs in nature as a decay product of thorium and uranium. Livermorium is a synthetic radioactive element. Its symbol is Lv, atomic number is 116, atomic mass is 292 and its electronic configuration is radon 5F14 6D10 7S2 7P4. It has been produced only in a very small amount and has very short half-life, only a small fraction of 1 second. This limits the study of properties of Lv. Come to the atomic properties of group 16 elements. First one is electronic configuration. Okay, the valency shell electronic configuration of these elements is Ns2Np4. You can say for oxygen this value of N is 2. For sulfur this is 3. For selenium this is 4. Okay, in this case this is d orbitals are also there. In tellurium, what is the value of N? This is 5, and in polonium this is 6. Atomic and ionic radii. Due to increase in number of cells, atomic and ionic radii increases from top to bottom in the group. Clear? Ionization enthalpy. This is a decreases down the group. It is due to increase in the size. However, the elements of this group have lower ionization enthalpy value compared to those of group 15 in the corresponding periods. I think all of you know, because these group 15 elements have extra stable half-filled p orbital electronic configuration. Okay. Electron gain enthalpy. I think you are familiar with this term, electron gain enthalpy. This is the change in enthalpy when an electron is added to a neutral gaseous atom to convert into the anion. Okay, and in this case energy may released. But because of the compact nature of oxygen atom, it has less negative electron gain enthalpy. Remember it. Oxygen has less negative electron gain enthalpy than sulfur because of its compact size. Incoming electron feels somewhat a repulsion. Okay. But sulfur onwards, the value again becomes less negative up to polonium. Just you can see this is the deviation. Okay. General trend should be less negative from top to bottom. Okay, but oxygen has the less negative because of its compact size, electronegativity. Next to fluorine, oxygen has the highest electronegativity value amongst the elements. As we know, fluorine is the most electronegative element. Within group, electronegativity decreases with an increase in atomic number. What it indicates? It indicates that metallic character increases from oxygen to polonium. Now we'll discuss the physical properties of group 16 elements. Okay. Oxygen and sulfur are nonmetals. Selenium and tellurium metalloids. Polonium is a metal. And we already discussed that polonium is a radioactive element and it has a short half-life. That is, its half-life period is only 13.8 days. All these elements exhibit allotropy. The melting and boiling point generally increases with an increase in atomic number down the group. Okay, but again, if you see the melting point and boiling point, this for oxygen 55 to 393. This is 90 to 718. This is the large difference. Okay, why this is the large difference? Large difference between the melting and boiling points of oxygen and sulfur may be explained on the basis of their atomicity. Actually, oxygen exists as diatomic molecule O2, whereas sulfur exists as polyatomic molecule S8. I think you can understand this concept. Smaller the molecule, or we can say smaller the molecular mass, magnitude of van der Waals force is less. That's why less amount of energy is required to melt or to boil. Clear? Oxidation states and trends in chemical reactivity. The elements of group 16 exhibit a number of oxidation states. You can say like oxygen -2, -1, 1 and 2, sulfur -2, 2, 4, 6. This is -2, 2, 4, 6. This is again -2, 2, 4, 6, but this is only 2, 4. Stability of -2 oxidation state decreases down the group. Okay, polonium hardly shows -2 oxidation state. As we discussed it, from top to bottom the metallic character increases and generally metals do not show any negative oxidation state. Okay, since electronegativity of oxygen is very high, it shows only negative oxidation state as -2 in most of its compound. Okay, but number of exceptions are there, except in case of OF2, where it has oxidation state is +2. Why +2? Because fluorine is more electronegative than oxygen. In case of O2F2, this is +1, and in case of peroxides, this is -1. Other elements of the group exhibit +2, +4, +6 oxidation state, but +4 and +6 are more common. Sulfur, selenium and tellurium usually show +4 oxidation state in their compounds with oxygen and +6 with fluorine. Actually, highest oxidation state is exhibited with the more electronegative element. Fluorine is the most electronegative. That's why these elements show +6 oxidation state. But stability of +6 oxidation state decreases down the group. What is the reason? Reason is inert pair effect, and stability of +4 oxidation state increases. Bonding in +4 and +6 oxidation state is primarily covalent. Clear, students? Okay, thank you.